Good afternoon, everyone. Nana. Good afternoon. Yes, right. Uh, Yesterday we completed what, Nana? I think we entered into the sliding friction. What I remember. Am I right? Yeah, kinetic friction. Right, correct. Yes, exactly, Ishan. Thank you. Kinetic friction. And I said that kinetic friction is a constant. Fk equals to constant. And that is always equals to mu k into n, and it is less than FMS. What the conclusions yesterday we took? Any wrong in my conclusion, Nana? Yesterday's part? I think this is the last point what we discussed. No, yes, correct. Okay. So here there are no conditions to discuss. Okay, what is the static friction and what is the limiting friction, whether it is whether it moves or not, right? There are no conditions, right? Then how to use this kinetic friction when we come to numericals? Why? Because we have only one formula for kinetic friction. That is straight away mu k into n. That's it. Whatever the n value you get, that we substitute here and finds the kinetic friction. Okay. Now here straight away after discussing only one formula, we are going to here take few models related to the kinetic, if possible, the static. Okay. Right. Come to here. First one. Here, suppose if I ask related to this kinetic friction, first question. On a surface, on a rough surface, what he said, the coefficient of static friction is equals to say 0.4 and coefficient of kinetic friction is 0.2. Okay. What he is saying, the minimum force required for what purpose, sir? Just to slide. Oh, minimum force just to slide means you are saying FMS, sir. Yeah, FMS. Okay, that much force, suppose the minimum force is 10 newtons just to slide. That 10 newtons, when I am applying just to slide, is applied, okay, after coming into motion. I'm not using that 10 newtons to bring it into motion. Okay, I applied that much amount of force after coming into motion, is applied after coming into motion. The acceleration of the body kept on the surface. That's it. Okay. Here, first try to understand the question what he said, Nana. Then you will get some idea. If you understand the question properly, you will get the idea. So here, first what he said, this is a rough surface. So first I drew there one rough surface. Now some mu s value, coefficient of static friction, coefficient of kinetic friction, both are given. Okay, why he gave, we don't know. He is saying that the minimum force required just to slide. Oh, he is trying to slide something here on the surface. Okay, something here he placed on the surface and he is trying to slide. Okay, maybe some force is applied. This is the applied force, capital F. Okay. How much force he applied? The minimum force required just to slide. Oh, this force applied is equals to the minimum force just to slide is FMS. Okay, that much force, which is the minimum force required just to slide, is FMS. Okay, that is the minimum force. That much force is applied after coming into motion. Oh, it is already in motion. Okay. Since force we are applying in this direction, here I am going to assume the acceleration in the direction of force. Oh, it is already in motion. Already in motion means friction, I think, is not static friction. Opposes the motion. This should be kinetic friction. Okay. Sir, now I understood the question, sir. Okay. Oh, this is the applied force, sir. After coming to motion. So this is the friction, sir, kinetic friction. Okay. And here it is moving in this direction means out of these two, which is greater, Nana? To move towards right. F is greater or Fk is greater to move towards right. Capital F is correct. Greater. Okay. So explanation I am coming to here. Since the block slides towards right, I say F is greater than Fk. F is greater than Fk means suppose this is 20 newtons and this is 5 newtons. How much you say the net force? Is it 25 or 15? Net force 15. How can you say it is 15? Since they are in opposite direction. Right, correct. That is 20 minus 5. Right. Good. Since they are in opposite direction, 20 minus 5 means F net I have to take F minus Fk. That is F net. That implies F net equals to F minus Fk. F net, all of you know, the formula is always MA, F net. Okay, Newton's law is equals to F. F is FMS minus Fk. FMS, shall I write it as mu S into N? And Fk, straight away, there is only one formula, that is mu K into N. Yes. So that once you check here, oh, good. Right. So that is your answer. No problem. So I take here N common, N into mu S minus mu K. Okay. On horizontal surface, all of you know, N is balanced by whom? Normal reaction is balanced by always mg on horizontal surface. So N on horizontal surface, anybody can say that is equals to mg, sir, mg into mu S minus mu K. That is equals to ma. So m cancels, sir. Now I got one shortcut formula, sir. G into mu S minus mu K. Oh. In any problem, suppose if they say the minimum force required to slide is applied after coming into motion, directly I can use this formula without deriving all these things in objective. Okay, so straight away you can say that. Okay, so directly after getting the shortcut, I say A is equals to G10, mu S is 0.4, mu K is 0.2, subtraction is 0.2, 0.22 into 10 is 2. Very good. A is equals to 2 meter per second. So that's it. Very simple. Okay. So here we did not find, I think, any hiccups. Very easily we solved. But we have to understand the question properly, what he gave here. So all of you followed this one, Anna, and the shortcut also. G into mu s minus mu k. Okay, good. Followed. Very good. But conditions apply, Nana. That condition already I underlined here. Minimum force required just to slide. If he gave that condition, then straight away we go to this pink color box. And then in just one step, we say the answer. Okay, this is time saving. Okay, good. This is one model. And look at another model, Nana, here. What he says, same on a rough horizontal surface. Yeah, good. Horizontal surface. The angle of friction is 37 degrees. Okay, means you can say mu s value, right? Here, to get an acceleration of 2 meter per second square. Okay, he said the force required is say some 20 newtons. Okay, to double the acceleration, what is the force required? How much force is required? Simple. How much force is required? Okay. If you want to take m value, m is, of course, if required, use it. Take it as some 2 kg. G, as usual, 10 only now. Okay. So here, if you want to think, you can think, no problem, right? Otherwise, just to follow my steps, what I'm saying here. I think if you read the question properly here, yeah. If you understood that question, then you can solve by your own. Okay, without waiting for my method. So you can follow your own method and try to say the answer. On a rough horizontal surface, angle of friction given means I think he gave here some mu. Whether it is useful or not, we don't know. So if I come to the solution part here, on horizontal surface, tan of angle of friction gives mu s value. That what we know. Yesterday, what we discussed. I think all of you remembered. Okay. That implies mu s is equals to, I am getting, yes, tan 37. Tan 37 is 3 by 4, means 0.75. Okay. But it is useful or not, that I don't know. Okay. We have to check whether it is useful. Really, this value is useful or not. Okay. Just or else unnecessary data. That I don't know. Now again going back and reading the question. To get an acceleration of 2 meter per second square. Oh, already acceleration is there. Means applied force is greater than kinetic friction. It slides, so kinetic friction is there. So F net is equals to, as usual, F minus Fk I take. Okay. So straight away I'm going to this formula from the previous example. F net is equals to F minus Fk. Why? Because he gave some acceleration. Means already he said indirectly it is sliding. F net we write it as Ma, that is equals to F minus Fk. Okay. When a body is sliding, then to find out the acceleration, we are going to use this formula F minus Fk by m instead of F by m. Okay. If the surface is smooth, then we use the formula acceleration is equals to F by m according to Newton's law. If the surface is rough, instead of F by m, we are going to use F minus Fk by m. Now is it clear, Nana? Okay. On a rough surface, next directly we go to use this formula. Okay, without deriving. Good. So from this formula, what I am going to do, yes, good. The information I am going to substitute here. First, he said acceleration is 2 meter per second square when the force applied is 20. Acceleration is 2 when the force applied is 20. So 20 minus Fk by mass, anywhere given? Given. Mass is equals to 2 kg. So that I substitute here. Okay. So by taking cross multiplication, I will get 4 is equals to 20 minus Fk. Happy. Fk I am getting here. That is equals to 20 minus 4. That is 16 newtons. Okay. This one is unnecessary. Anywhere we did not use. Okay. Waste unnecessary data. Confused. That's it. Okay. And here, and here to double the acceleration. You got 24, Nana. More. Okay, I will check it. Second time he gave. Now the acceleration is 2 times to initial acceleration. That is 4. If A is equals to 4, then F is equals to how much he asked. Okay, to double the acceleration, previous acceleration 2, double means 4. What is the F? Okay, then we check. Tanisha, I think correct. Lakshmi Gayatri, once you check, Nana. A is equals to our formula F minus Fk by M. Yeah, I think all of you correct. Lakshmi Gayatri only have to check. 4 is equals to F. I don't know. Fk. Yeah, Shrestha correct, I think. Okay. Fk is 16 by M is 2. 4 2s are 8. So 8 is equals to F minus 16. Yeah, so I'm getting F is equals to 16 plus 8. That is 24, Nana Lakshmi Gayatri. Why you got 36? I don't know. Right. Maybe some calculation mistake. Okay, now you understood this method, Nana? How to find the acceleration when a body is sliding on a surface? Yes. So second model is also over. In this case, yes, what he gave is just unnecessary data. Why? Because separately we calculated Fk, that is not required for us. F is 24, Nana. I don't think it's so. Yeah, 2 2s are 4, 20. Fk is 20 minus 4, kada Nana. Dornala. Era, is it 16 or 24? Frictional force. FK. 16 only. I think you are saying FMS emo nana. FK is 16 kada nana. 20 minus 4. FK taken to the other hand. Correct. If you want to calculate FMS you can calculate by using the formula mu s into n. Yeah, that may be 24. I don't know. I did not check actually. Mu s is equals to 3 by 4. A normal reaction mg. 3 by 4 into m is how much given? 2 kg. 2 into g 10. Even this is also 20. 5 3s are 15 gadanana. This is FMS. I think even that is also not 24. How you got 24? I don't know actually. Answer. Okay. Answer is 24. Okay, right. That is 24 only now. Good. Right. Leave it. And then here, okay now. Suppose if I come to the case, this is a vertical wall. And on the vertical wall, I placed one duster or surface, block, like this. Initially, already I told, if you place like this, because of weight, pakka it will fall down. Okay, surely it will fall down. So to keep in contact means to generate the normal reaction, we have to apply some force like this. Sure. If you apply the force, then immediately it is in contact with the surface and immediately that will create the normal reaction. This is the direction of normal reaction. Okay. In this case, suppose F is equals to 10 newtons. Okay. Mu static is equals to here say 0.6. Okay. And mass of the block M is equals to say 500 grams. Okay. Find the frictional force between the surfaces. Between the block and wall. Block and the wall. What's Resta? FMS should be greater than FK in above problem. Yeah, correct only, Nani. You are right. Why? Because FK should be less than FMS. Maybe that angle of friction not 37. Just he gave here to confuse. Okay. So maybe that data are wrong. Which one? 37 may be wrong. So is it clear? Shrestha Nana? Yes. Right. Good. Come to this problem, Nana, here. When we come to in this problem, Because of mg, it will try to slide down or up, first of all. It will try to slide down. That's why here, since its tendency is to slide down, friction will act in opposite direction. Yes, exactly. This is the direction of friction. Yes. Okay. Uh, Including the direction you are saying, Nana, Lakshmi Gayatri. Okay. Friction. Yeah. Okay. Right. Yeah. No problem. But is that you check, Nana, whether the body slides are in motion, that is at rest, slides or rest. Did you check that? Okay, we will check it. No, first you have to check it now. Why? Because FMS is equals to our formula mu s into n. But in this case, n is mg or f normal reaction equals to. Is it mg or f? F. Very good. That identified quickly. Nice. Here, n, that is in opposite direction to not mg, in opposite direction to f. So I can write FMS is equals to 0.6 into n. N is f. F is given as 10. So this is equals to 0.6 into 10. That is equals to 60 newtons. Okay. But the force which it tries to slide the block is, this is 6. Yeah, correct now, Ishan. This is 6. Yeah. Okay. Don't score. Right here, this is 6 newtons, right? And then here, what I'm saying, the force which it tries to slide the block downwards is mg. So F external is equals to here, F external acting on the body equals to, or simply F, which it tries to slide the block is equals to mg. That mg, how much? If you check there, mass is given as 500 grams, Nana. 500 grams means 500 by 1000 kg. Yeah. Into G is 10. So that you are getting 5 newtons. So check here. The force which it tries to slide the block is less than FMS or greater than FMS? 5 is less than 6. Am I right? Yeah, less than 6 means pakka the body is at rest. Why? Because minimum force, rest. That implies. Very good. I think you understood. That implies the body is at rest. At rest, I have to say Fs is equals to applied force F, okay, which tries to slide. So which it tries to slide means, is it 5 newtons or 10 newtons? Which it tries to slide. Is it 5 or the applied force 10? Which it tries to slide, not to press. Which it tries to slide is 5. That's why answer is, don't say 10. This is 5 newtons. Now you understood this model, Nana? Okay, good. Okay. Right. So is it clear or a bit confusing here? Yeah, good. Understood. Okay, right. So no problem here. Very good. Good. Same thing if I ask like one problem here. Example, he is one cliffhanger, means who tries to climb the hills, okay, by taking the support of other hill. Okay, cliffhanger, one person. Okay, this is one cliff, means hill, and this is other cliff, means hill. Between these two narrow hills, hills with a narrow valley in between, narrow gap, narrow valley in between them, he tries to climb up. While climbing up, he has to take some rest in between. Okay. In the middle, since the two hills are very close and narrow valley is there, narrow gap is there between them, he sometimes, while taking rest, take the support of other hill like this. The valley is narrow, yes, and he tries to rest his back here by putting his back, by pressing the other hill with his back. Okay, and then here holding the two legs, okay, tightly there at the other hill, and here he is trying to eat something or drinking water in the middle. Okay, he is a person. In this case, the person, okay, taking rest between the two hills, okay, is not sliding. He is not sliding. He is not falling down. Okay, means he is some expert cliffhanger. Okay, in that case, he found some friction here at the first hill. Okay, when he tries to, he will try to fall down or up, Nana. If he loses it down means friction will act in the opposite direction. So at the first heel, at the legs, you will find some friction. And because of this back taking the support here, he will get another friction here at the other heel. So two frictions you are finding out, like here F1 and F2. Okay. In the figure, given that F1 is equals to 2F2. Okay. Mass of the person, okay, Indian standard weight 60 kg. Okay, Indian's weight, standard weight 60 kg. Yeah. Then find the frictions at the two hills. I think you can say the answer. Very simple question. Anyone got the answer for it? Okay, why you people are thinking, I don't know. The person clearly he mentioned taking rest. Oh, Lakshmi Gayatri got the answer. Don't think it's so, Nana. I think your answer is wrong. Why? Because he is at rest. At rest means downward force should be equal to the total upward force. Downward force is only his weight. Okay, only his weight. Above. Shrestha, I think you are 100% wrong, Nana. This is mg. Who is this? This is mg. And here you will get the two frictions, one at the legs, other at the back, like this. The two frictions. You will get here, this is F1 and it is F2, where F1 is equals to 2F2, what he gave. He is at rest means simple logic. The total downward force should be equal to total upward force. Okay, total downward force is mg. Kavita, Shravanti, Kavita. Okay. This is mg, and here, maybe correct, Nana. You are right, I think. Equals to total upward force is F1 plus F2. Upward force. Downward is mg. So I think now you can get the answer very easily now. Mass is 60, G is 10, that is 600, is equals to F1, that is 2F2 plus F2, that equals to 3F2. That implies you are getting, by cancelling the term here, F2 is equals to 200. Yeah. And F1 he gave, that is equals to 2F2. 2 times 2F2, that is 200, that is 400. 2 into 200 is 400. Simple. Okay, well, I don't know why you did not get the idea here for this question. All right. Okay, leave it. I think now you are able to understand how to find the frictions here on the horizontal surface and on the vertical surfaces, like one wall and two walls. Okay, yeah, good. So horizontal and vertical part over, Nana. Now you are coming to here, rough inclined surfaces. Okay, on the rough inclined surface, what happens, sir? First, here I am assuming the inclined surface, and this is the angle of inclination here, which is theta. Okay, and a block is placed on the inclined surface like this. This is the block placed on the inclined surface. Okay, Nana? On the inclined surface, if I ask what are the forces acting, I think very easily you can say many forces here. Number one, if I ask who is this, you can respond very quickly. Who is that? Who is this green color one, Nana? Quickly. Normal reaction. Very good. Right. Normal reaction. And after resolving the components of weight, Quickly respond. Who is this one? Fast. Mg sine. Very good. This time Ishan responded quickly. Mg sine theta. Very good. And here, who is not mg? Mg sine theta. Okay. Right. Then who is this? Mg cos. Super. Mg cos theta. Very good. And it is in a tendency to slide down. So oppose that one. You have to take someone here like this. Who is this red color one? To oppose the motion. Friction. Very good. Friction. These are the forces acting on the inclined surface now. Okay. Very good. Whether the body slides or not, Pakka N is equals to mg cos theta. Why? Because along that y-axis direction, there is no motion. Okay. And if the body is at rest, then F is Fs, static friction. Static friction is always equals to applied force. Applied force is sliding that one. The force which is sliding is mg sine theta. So Fs is equals to mg sine theta. Do you have any doubt on this point, Nana? When the body is at rest, do you have any doubt? No. Okay. Then the body which is at rest here on the inclined surface, here, how to slide it downwards? By increasing the sliding force. Am I right? Means by increasing mg sine theta. If mg sine theta is increased, then here the friction is also increases and reaches to one condition called limiting friction, FMS. Okay. That time, what is the here angle you are taking is called, we are naming it. Simple, and I don't know whether you understood or not. Suppose if you want to increase this mg sine theta, no need to increase the mass of the block. Just increase the angle of inclination. If you increase theta, sine theta increases. So that mg sine theta increases. Okay. That is what I'm saying. So today already it is 3:15. We will come to one conclusion here. Okay. And later we stop it. So coming to the conclusion here, by increasing the angle of inclination, mg sine theta increases and at a particular angle, okay, hey, at a particular angle, the body is ready to slide. Okay, at that instant, what is the angle of inclination? I will explain it in next class. Okay, so I'm going to stop it. If you have any doubts, you can ask, or else we will leave. And those who want the pics here, you can take. Yeah, good. This is the first page. This is the second one. Okay, now. This is the third one. Thank you, thank you. And this is the fourth one. Okay, Nana. Bye everyone, Nana. We'll meet on Friday. Okay.